The AgriWebb system embodies food sovereignty as a democratic design principle by embedding control, participation, and accountability directly into the structure of food production itself. Rather than treating food as a commodity delivered through distant and centralized supply chains, the AgriWebb food system organizes production through locally governed farming and distribution operations. By integrating food production with workforce development, education, energy generation, and resource cycling, the AgriWebb transforms access to food from a passive outcome into a shared civic function. This structure ensures that communities are not merely consumers of food but co-designers, operators, and decision-makers within their food systems. In doing so, the AgriWebb operationalizes food sovereignty by aligning agricultural infrastructure with democratic values, creating resilient, transparent, and participatory systems capable of sustaining both food security and civic empowerment. The AgriWebb, an integrated, carbon-negative community food system. The AgriWebb is a fully integrated food, energy, and carbon management system, designed to operationalize food sovereignty at scale, while remaining economically viable, environmentally regenerative, and democratically governed. At its core, the AgriWebb combines biological systems, aquaponics, algae cultivation, anaerobic digestion, vermicomposting, and solar energy generation, with a community-based organizational structure composed of AgriNodes and AgriHubs, which combine to form regionally coordinated agri-clusters. The result is a region-wide locally controlled food system we have dubbed the AgriWebb. The AgriWebb transforms food production from a linear extractive process into a circular, carbon-negative system that produces food, clean energy, fertilizer, workforce opportunities, and carbon credits simultaneously. The AgriNode at the production level, AgriNodes function as high-intensity microfarms capable of producing large volumes of ultra-premium organic food on minimal land and water footprints. These nodes utilize aquaponics, hydroponics, and vertical growing systems that use up to 90% less water than conventional agriculture, integrate fish, plants, and microbial ecosystems, and rely on natural organic biological inputs, as opposed to synthetic inputs. Vertical growing systems, controlled environment greenhouses, and smart sensor networks maximize yield, efficiency, and resilience while enabling year-round production in diverse climates. The AgriNode also serve as primary sites of carbon capture using cultivated algae, characterized by rapid growth, and duckweed, up to 40% protein. We also capture carbon in cover crops and biochar. Several AgriNodes surround and support food processing and distribution at AgriHubs, which also act as the social, technical, and economic backbone of the system. AgriHubs conduct farmer training, workforce development, food processing, distribution, technical support, and food literacy education. AgriHubs aggregate outputs from multiple AgriNodes, manage value-added production, and ensure that food is distributed within the communities where it is grown. In doing so, AgriHubs convert biological productivity into stable employment, skills development, and local economic stimulus. Anchoring food systems within democratic community institutions rather than distant corporate supply chains is a pragmatic approach to strengthening our democratic republic. Multiple AgriNodes, affiliate with a single shared AgriHub, together form a community-based, seed-to-sale supply chain, known as a neighborhood agri-cluster, physically located within the community it serves. These agri-clusters represent a critical structural innovation. They align food production, governance, and consumption within the same geographic and social space. At the regional level, agri-clusters share real-time data on crop yields, energy production, fertilizer output, and consumer demand with each other, enabling regional coordinated planning without centralized control. This regional coordination allows the AgriWebb to function as a distributive food system, created, operated, and governed by the people who depend on it, while maintaining efficiency, redundancy, and resilience. What distinguishes the AgriWebb from conventional food systems is its circular integration of food, energy, waste, and carbon. Solar panels generate clean electricity. Biomass and organic waste are converted into biogas through anaerobic digesters. Digestate and worm castings become high-value organic fertilizers. Excess energy and fertilizer are sold into external markets. Carbon dioxide generated in farming operations is not released into the atmosphere. Carbon dioxide is recaptured to enhance greenhouse productivity and stimulate algae growth. This closed-loop architecture allows the system to produce surpluses of food, energy, fertilizer, and carbon credits that exceed internal needs. These resources become opportunities for multiple non-traditional revenue streams. The AgriWebb is a revenue-generating business model rather than a cost center. Taken together, These elements position the AgriWeb as both an economic engine and an institutional democratic infrastructure. It demonstrates that food sovereignty does not require isolation from markets or technology, but rather control over critical systems and flows. By embedding food production within locally governed structures, while leveraging advanced ecological engineering, the AgriWeb reconciles environmental regeneration, economic resilience, and democratic participation into a single, coherent system. It is not simply a way to grow food, it is a way to design power, sovereignty, and sustainability into the material foundations of society. In the following episode, we will explore the systems needed to create the Agri-Cluster, and how these Agri-Clusters regional AgriWebs